All right, everybody. Today we are going to do our warm up. So, day 4, please have your warm up out and let's start going over counting NO3. How many N is there? How many nitrogens? Is there a subscript or a coefficient? Nope. So, we are going to assume that it's 1. O3. Is there a coefficient in front of that? Nope. So, we're only going to focus on the number right behind my subscript, which is going to be 3. I have 2 BrO2. So how many BRs do I have? We're looking at that number in the front. So that is going to be 2. Now that coefficient must be distributed to each of these elements. So as we just did, 2 times 1, which is 2. Now we need to do oxygen. So we have our coefficient times our subscript. That has to be distributed. So 2 times 2 is 4. Now, looking over here at my BR, how many BRs do I have? I have 2. There's no coefficient in the front, so we're only looking at the subscript. So I have 2. Oxygen does not have anything, so we assume it's 1. And then hydrogen has that number 2 right back here. All right. So what are we doing today? Today we are going to be balancing equations. So last class we worked on counting. Now we're going to be balancing. So you're going to have worksheet number 1 that you're going to work on with me with this video. Then you're going to try worksheet number 2 by yourself. Okay. So my fact of the day is, what is the chemical formula for banana? Banana 2. All right. Here is our table of contents. If you can please write this down. Pause the video. Page 43 is balancing. 44 is you try, count, and balance. So let's review from last class. Remember, the number in the front is going to be our coefficient right here. The number in the back is going to be our subscript. So how many carbons do I have? I have 5. Let's count them. 1, 2, 3, 4, 5. How many hydrogens do I have? Well, we're looking at that subscript. We have 12. Let's find them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is one molecule of C5H12. What happens if I put a 5 in front? That coefficient means that I have 5 different molecules, right? I have 1, 2, 3, 4, 5. I have 5 C5s H12s. Now you could actually sit here and count each of these carbons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Whew. Or you can make your life so much easier, and you could literally do 5 coefficient times your subscript. 5 times 5 is 25. Now, once again, you could sit here and count all of these molecules up, or you can just do 5, my coefficient times my subscript to get 60. Your choice. But remember that anytime I have a number in the front, that means I have 5 of these. So 1, 2, 3, 4, 5. Okay. Now, if you need help counting, please refer back to this chart that we did last class. This will help you count, and it'll help you tell you how many total atoms there are. But this is the worksheet we are going to work on today. So please make sure you put your name on this, class block, and binder page. This you are going to put in your binder when you're done. You're not turning this one in, okay? So let's start with why we balance equations. We balance equations because atoms are neither created nor destroyed. They're only going to be rearranged. So that means that your reactants and your products must equal. They must be the same. So as it says here, mass of the products must equal the mass of the reactants. And that's why we balance them. Now, you might see or hear me talk about diatomic. What diatomic means is it's just 2 of the same element. Well, there's 2 hydrogens, there's 2 oxygens, 2 chlorines. You get the idea, right? There's 2 of those. To extend this a little further, you might also hear me say mono, which means 1, or di means 2, which is what we just talked about. And 3 might be tri. Those are our prefixes. So these are going to come at the beginning of the word. So if I'm talking about carbon monoxide, we'll look back at mono. How many are we talking about? We're talking about one. So carbon here, oxygen's on this side, carbon monoxide. If I'm talking about carbon dioxide, something you've heard before as well, that means two. So I have two oxygens. I have two oxygen, one here, and carbon's right here. So when we are working on elements, it might be in a word form. It might also be in the symbol form. So let's talk first off what a product and a reactant is. So the reactants are going to be on the side where the elements would be kind of like separate. Okay. So like right over here, we have hydrogen 2, we have oxygen 2. This is going to be my reactants. This side over here is going to be my products. So I'm combining these two and these two to make a product. So let's just think about baking for a minute. So 2 ingredients that you use to bake cookies would be like 2 eggs and maybe a cup of flour, or right? You're going to definitely have some kind of eggs and probably flour. So you have your eggs, you have your flour, that's going to create your cookies. So your reactants are what you start with, and the products are going to be what you end with. Now, before I go to this slide, I want to show you how these are a not balanced equation. If I was to ask you how many hydrogens I have 2. How many oxygens do I have? 2 on my reactant side, which means that they're supposed to be equal. Okay. So this side over here means I have 2 hydrogens, but I only have 1 oxygen. So that means we're not balanced. And we're going to talk about today how to balance these equations. Just keep in mind that the reactants are what we basically start with. Okay. They're the ones that probably going to have elements separated by a plus sign. And then these are our products. And this arrow basically means yield. Okay. And we're going to talk about that in a couple minutes. So as a quick reminder and a visual, reactants are the ingredients that you start with. So like our flour, eggs, and sugar. Products are going to be the new substances that are formed from those ingredients. So I have my cake. All right. So let's look at this equation here. The first thing I can always tell you is that it is essential that you put the element on the left side and the element on the right side the exact same way. So let's first count them, okay? How many marshmallows do I have? Well, I have 1. How many graham crackers do I have? I have 2. How many pieces of chocolate do I have? I have 2. So what I mean by having the same element, we are going to do marshmallows first. We have to have marshmallows here, graham crackers here, chocolate here, chocolate here. I promise you, because when you do it like that, when you start balancing, it makes your life like 10 times easier. And my goal is to make your life 10 times easier. Okay. I'm not trying to make it complicated for y'all. So how many marshmallows do I have on the side? I have 1. How many graham crackers do I have? I have 2. How many chocolates do I have? I have 3. All right. So pause this video and see if it is balanced. So I have 1 marshmallow, 1 marshmallow. I have 2 graham crackers, 2 graham crackers. So far, everything looks balanced. But when I get down here to my chocolate, well, I have 2 chocolates on this side and I have 3 chocolates on this side. That means that this is not a balanced equation. And in order to balance this, we need to change our coefficient. So if I have 2 over here and 3 over here, what you can do is just multiply it by the other side. So if I have, or something known as the least common factor, okay, or denominator. So I have 3 on this side. I have 2 on the side. So I'm going to multiply this by 2. So 3 times 2 is 6. So this number, whatever I times it by, becomes my coefficient. So I'm going to bring this 2 right there. Okay. But that also means that I need to distribute this 2 into each of these. Anytime you have a number in the front, the coefficient, it has to go to each of these that are in this part of the equation. All right. So that means I have to do 2 times 2 for my graham crackers, which is going to give me 4. My marshmallows, I have to distribute 2 times 1, which is going to give me 2. So now let's see if everything is balanced. 1, 2, 2, 4, 2, 6. They are not balanced. So I need to come to this side and change these coefficients here to match what it equals. Okay. So let's start with my chocolate. So I had 2. I'm going to times it by 3 because I want them to equal. This number and this number must equal. So I'm going to put a 3 right in front of my C because 3 times 2 is going to be 6. Now let's fix another one of these. Let's fix our graham crackers. You look on the right side, okay, they're equaling 4. Well, I have 2, so 2 times 2 is 4. So I'm going to put a 2 right here. And now I need to fix my marshmallows. So now I have 1 over here and 2 over here, so super easy. I'm going to times it by 2. This number right here that I times it by goes in the front for my coefficient. So take a minute and look this over. All right, now let's see if all of my items are matched, okay, all my elements. So I have 2 marshmallows over here. Well, I got 2 marshmallows over here. Check. I've got 4 graham crackers over here, and I got 4 graham crackers over here. Check. They are balanced. I have 6 chocolate over here and 6 chocolate over here. Check. This is now a balanced equation. Everything on my reactant side and my product side are going to be balanced. So pause your video, and on the next part, I would like you to look at these words: subscript, coefficient, yield, reactant, and product. And I would like you to try in these boxes here, put your vocabulary word in here. So before we get started, you feel good about where all of these words are if I start using those terminology. All right, everybody. So we are talking about this green part right here on the left. So I have 2 different elements that are separated by a plus sign. Those are called my reactants. Over on the other side, I have this one, which is NaCl, and that is going to be my products. Okay. Now, this little number right here is called my subscripts. That is the number of atoms I have. So I have 2 chlorine. Okay, I have 2 chlorine right here. Now, your coefficient is going to be the number of molecules I have. So see how I have NaCl? That means I have 1 molecule. Now, if I put 2 in front of here, well, then I'm going to have 2 NaCl. So coefficients tell you the number of molecules, and subscript is going to tell you the number of atoms I have. And that little arrow right here, that is just telling you your yield. It's kind of almost like what equals, but we're just going to talk about it like as a yield for today. One more time, just to make sure everyone understands, coefficients are the numbers that are placed in front of the chemical formula to balance that equation. That is the only thing you can change. They get multiplied by the subscript. You can change those. I'm going to emphasize that again. You can change your coefficients, but your subscripts, these are the smaller numbers that are within the chemical formula. They indicate how many atoms of the element in a single molecule. You can never change these, as it would change the chemical identity of the substance. So we are not able to change the subscripts. We are only going to be changing our coefficients. So I just want to take a minute to make sure you guys understood that. And the last thing as a reminder is your reactants and your products must equal each other. They have to be balanced. And if they're not balanced, then we have to change our what? Our coefficient, which is the numbers in the front. All right, everybody, take a deep breath, and we are going to start with counting this equation. So I have Cl2. How many Cl's or chlorines do I have? I have the number 2, okay, because that subscript is indicating 2. How many Na or sodiums do I have? I have 1. Now looking over here, I have how many chlorine and how many sodiums? I have 1 and 1. Now, as a reminder, and I'm going to emphasize this every single time we do these problems, I need you to make sure that when you are counting, you have the element on the left matching the element on the right. You have to have chlorine at the top and chlorine on the top. You can put Na on the top and Na on the top. That doesn't bother me. But what I need you to do is make sure that whatever element you put here must be the same element on here. I promise you, when you get to high school, you'll thank me. It's going to be important because you're going to be doing more intense balancing problems, and it really helps if you keep your elements the same on each side. So let's look to see if this is balanced. I have 2 and 1, 1 and 2. It is not balanced. I have more chlorine on this side. So this is an unbalanced equation. So if this is unbalanced, then we need to fix it. And how are we going to fix this? Is over here, we have 1. Well, how do I get to 2? I'm going to times this by 2. Okay. So I have 1 times 2. Okay. Which is going to give me 2 chlorines. I have 1 times 2, which is going to give me 2. So I put a 2 here, and now that's going to change these. Now over on this side, I have to fix my Na. Okay, so let's kind of give you a visual over here. So if I put a 2 right there, 1 times 2 is 2. That coefficient has to be distributed to each of these. So that means now I have to fix the other side. So on the other side, in order to fix it, I put a 2 in front, and then I'm going to put a 1 right here because now I have 2 and 2 and 2 and 2, and everything is now balanced. So whatever I do, if I'm fixing it on this side, I need to make sure that at the end it balances on this side. We're going to do some more problems. So let's look at the next one, okay? So first, I want you to pause the video, and all I want you to do is just count how many K, Cl, and O's we have. All right, let's see if you got what I got. I have 1 K, I have 1 Cl, and I have 3 oxygen. Let's go to the other side. How many Ks do I have? I have 1. How many chlorine? I have 1. And how many oxygen do I have? I have 2. So let's see if this is balanced or unbalanced. I have 1 and 1, 1 and 1, 3 and 2. This is not a balanced equation, so we need to balance it. So what do I do first? You're probably like, ooh, well, 1 and 1, 1 and 1 is fine for now. We have to fix our O's. So over here I have 2, and over here I have 3. So what I'm going to do is I'm going to times it by the other side, or once again known as the least common denominator, which 3 and 2 both are going to go into each other as 6. So this right here, this number 2, is going to go to the front of my molecule. This is going to be 2. So I'm going to have 2 of them now, okay? Over on this side, I'm going to times it by 3. So I have this side by 2 and this side by 3. So now you might be like, all right, Miss Bandy, it's good. It's not. It's tricked you. So this coefficient has to be distributed to each of these. Okay, so I have to take this 1, and now it has to be times by 2. Okay, this goes to each of these elements. So now I have 2 and 1, 2 and 1, and 6 and 6. Is this going to be balanced? Still not balanced. So this side has 1 more. So we need to, it's at 2. So we have to times this side by 2. So now if you were to go back and check yourself, you're like, this K is 2, and the K is 2. The Cl is 2, and the Cl is 2. The O is 6, the O is 6. Now everybody's happy, and we can smile and keep going. But yeah, this is now a balanced equation. Everything is equal on both sides. Going back to the idea of the law of conservation of mass, where atoms are neither created nor destroyed, they're only rearranged, and they must be the same before and after. You guys are getting it. Great job. You got this. All right, so we are going to go to, let's see. Yep, we're going to go to this problem now. So I want you to pause and I want you to try and count this one for me. All right, so how many mg's do I have? I'm going to have 1. How many H's do I have? I have 1. How many chlorines do I have? I have 1. Going on the other side, how many mg's do I have? I have 1. How many hydrogens do I have? I have 2. And how many chlorine do I have? I have 2. So is this a balanced equation? This is not a balanced equation. This is unbalanced. So we need to fix this side right now, okay? So if I have 2 over here, I'm going to times this by what? I'm going to times this by 2. So this number here, this red number, whatever I times it by, goes in the front of like my coefficient. So I'm going to bring it right there. And now we're going to check to see if everything is balanced. I have 1 magnesium, 2 hydrogens, 2 chlorines, 2 chlorines. Everything is balanced. It is happy now. Okay. Now you can technically leave this blank. I'm fine with it because if it's blank, we assume it's 1. But if you prefer to put 1, 1, 1, that's fine. But if you leave it like this, I would totally accept it as correct. Okay. I want you to pause and I want you to try and count this one for me. All right. So we have H2N2, which is going to yield to our product NH3. So let's see if you counted it right. Did you get 2 hydrogens, 2 nitrogens on the left side? Did you get 3 hydrogens and 1 nitrogen on the right side? So is this balanced? Unfortunately, it is not. So my question to you is, how can we balance this? And where do we start? Because if I was you, I would be like, well, there's quite a lot to fix, right? And it doesn't really matter which one you fix first, because in reality, if you fix one, then you could fix another element right afterwards. But I would personally, if I was you, I would probably fix my H's. So if I have 2 on this side and I have 3 on this side, I'm going to times it by the opposite. So I'm going to times 2 by 3. So 2 times 3 is 6. And over here, I'm going to do 3 times 2, which is 6. So this number right here, whatever I times it by, goes in the front as my coefficient. So I'm taking this 3 and I'm bringing it to the front. I'm going to take this 2 and I'm going to bring it to the front. Okay. So now what you get to do is look at your numbers. Is everything balanced? I have 6 and 6 and 2 and 1. Well, this needs to be times by 2. And you know it's going to be times by 2 because the 2 has to be distributed to each of these. Okay, so I'm going to do 1 times 2, which is going to give me 2. And now everything is balanced. I have 6 hydrogens on each side and I have 2 nitrogens on each side. So now we have an equation that is balanced. As I mentioned in the last problem, you are more than welcome to leave it like this, 3. You can also put a number 1 here, okay? Because this is just assuming that there is already a 1 if there's no number there. But your choice. I will not mark it wrong if you leave it like this, but just wanted to share with you that's your choice if you want to do that. This is the last problem you have until before I release you to do your second worksheet of this. Okay, so let's start first with just counting. All I want you to do is just count right now. So how many CAs do I have? I have 1. How many carbons do I have? I have 1. How many oxygens do I have? I have 3. Going over to the other side, how many, calcium do I have? Calcium, I have 1. How many carbons do I have? I have 1. And then over here, I have my first oxygen is going to be what number? 1. And then my second oxygen over here is going to have 2. So when your elements are separated by a plus sign, I like to keep them separate. I don't like to combine them. I just like to make a note of them. So like over here, I would make a note like 1 and 2 equals 3, but I would not combine them right away because if you were to change your coefficient on this, that's going to change your numbers. We'll get more into that probably as we do some practice examples on the second paper today. but I like to keep them separate, and that's just me. So I have one, and one, and I have 3 oxygen. And over here, you add these two together, which is going to give me 3. And so everything is a balanced equation, which means you don't have to do anything. You could literally leave it like this and just write balanced, and you're good. Like I said earlier, if you want to put the number 1 in front of the coefficients, you can. If you don't, then you can just leave it just like that. It's totally your choice. So I know that this was a lot in 25 minutes, but I'm extremely proud of you guys. Thank you for listening through this video. I would just like to emphasize 2 things. Make sure that your products and your reactants are going to be equal. Okay. Also, make sure that when you go to write your elements down, that you put them on the same order. So if I start with Ca on the left, you want to put Ca on the right. I just can't emphasize that enough. And then my last thing is, if you put a number in the front, your coefficients have to be distributed to each of those elements there. If there's a plus sign, you are not, if I put a 2 in front of the CaO, you don't have to put a 2 into this part of the equation. You're only doing it in the first part because there's a plus that separates it. So I just want to make sure I emphasize that too. All right, guys, super proud of everyone. We are going to do the second worksheet of the day. This worksheet will get turned into me. Okay. So the last little example here that I gave everybody, you will see O2 plus N2 yields NO3. So first things first is you are going to want to put it O and O together at the top, and then N and N on the top, or underneath it, sorry. So count your atoms. You're going to have 2 oxygen, 3 oxygen on the right, 2 nitrogens on the left, 1 nitrogen on the right. So this is an unbalanced equation, which means we need to balance it. So what I would do first is I would probably times the O by 3, and I would times this O by 2, and then that equals 6 and 6. And when I put that 2 in the front, I have to now times my nitrogen by 2. And if you do this, you will see that this is 6, this is 6, this is 2, this is 2. Okay. Once again, super proud of you all. There are a total of 6 problems I would like you to do. I would like you to show your work. I want you to show me how you count. I want you to circle if they're balanced and unbalanced. And if they're not balanced, I need you to then make them balanced. Okay. Please turn this worksheet in before you leave. This is going to be a grade. And then if you finish early, you can work on your digital notebook, or I have an Explore Gizmos for you guys to go to. I will also post things in Canvas of additional videos. If for some reason my teaching was a little confusing, there is another video that kind of walks through how to balance equations. Other than that, please be good, please stay awesome, be kind, and make sure you turn this in. Have a great rest of your